All right. Every session is going to be recorded, so I'll be sending you the recorded link to the session. All right. So so first thing is I want to um I believe there's a reason why you enroll for this program, right? Um, and then you want to upskill around data analytics, right? Which is very important. So I want to know how passionate are you? What's going to be your level of commitment to putting in the work in case you are given tasks to do or assignment and stuff like that. So I mean, I want to hear from you, right? I mean, this is like the first time I'm having a conversation with you. Yeah.
Okay, so yes, please. I'm trying to get into analytics because I'm currently in communications, but I'm trying to delve into analytics. So like there's many analytic roles open currently, and I don't know much about it. So I'm trying to, better myself and better my skills. So yes, um extremely what's the word I'm looking for now? I'm very committed to the class because I'm committed to my career growth basically. So yes.
Okay. So what that means is that you have to show this level of commitment, right? You have to be eager to learn. You have to
Yeah.
eager to practice, because it's not just to have a session. All right. Sometimes you have to also go out of your way to to practice, to work on assignments, to work on project, because projects will be given to you, and then you have to also be you have to be timely in your submission, right? So those are the things, because we only have 2 months, and then we want to maximize this time that we have together. All right. Afterwards, for each of the um skill that you're going to be learning, there'll be a capstone project. So for example, for Excel, you are going to do a capstone project. What that means is that on your own, you are going to develop or work on a project and then submit it and do presentation, right? And then for Power BI, the same thing. Okay, so for each of these skill, you have to work on the capstone project, right? So that at the end of it all, you have something that you can showcase in your resume, right? You can also put it as part of your portfolio. Okay, so
Yeah.
those things are very, very important, right? Um, of course, I'll be I'll be happy to give one or two support even after the training, just to guide you and stuff like that. So yeah, I just wanted to know your level of commitment, your desire, your passion to learn, to grow, and become a better version of yourself, even after doing this program for 2 months. All right. Um, so that's on that aspect. So the next thing I want to hear from you. What are the things you've heard around data analytics? Uh, why data analytics for you? Why data analytics?
So as I said previously, I'm trying to get into more analytic roles. So and I currently know nothing about Excel, about Power BI. I'm completely new to this. So I think, to be honest, on my part, it is mainly just I'm trying to grow in my career, and I was advised to pay more attention to Excel, because I think once you understand Excel, you can
Mhm.
go from there to anywhere,
Okay.
as I was told. So it's my my quest for growth comes from, like, just wanting to know to increase in my career. Yeah, so I want to be able to, handle more analytical tasks.
Okay.
That's what I to me. So yeah.
All right, that's fine. Okay, no issue. So it's gonna be beginner friendly. What we're gonna be doing is gonna be hands-on. What that means is that you'll be following set of instructions, set of guidelines. I'll be guiding you on what you need to do, right? When we get to where we are gonna be doing hands-on practical stuff, you're working with data, right? You're working with data. So I'll be telling you what you need to do and stuff like that. Right. So I'm just preparing you ahead so that you know that okay, you'll be following the instruction. You have to be keen, you have to be attentive to getting direction and instruction, right? So that you are the one doing it on your own. So by the time you are doing it on your own, it helps you to build a level of confidence. And then after the session, you can go back, watch the the session again, and then try to practice based on assignment or task given to you. So that's where we're going to be doing it, right? And also, I'm going to be integrating AI into our workflow, right? So that you get yourself familiarized with how AI comes into play when it comes to data analytics. Do you understand?
Yes.
All right. Okay. So I'll be sharing my screen now. So I'm going to be sharing a slide. So basically, it's just going to be an introduction on data analytics, on data, and stuff like that. So just a foundational thing that you need to know because you are just coming in, so you need to know certain things. All right. It's not just Excel. Excel is just a tool. All right. Data analytics is a skill. All right. Data analysis is a skill on its own. All right. So, but there is a tool that drive this skill. All right. So we have Excel, we have Power BI, and some other tools. But you need to know, or you need to have a foundation of data analysis. Do you understand? So those are things we're going to be looking at today, right? Yeah. So I'll be sharing my screen now. So let me know if you can see my screen.
Okay, I'll let you know when it has come up.
All right.
I can see your screen now.
Okay. So we're going to start from um, what data analytics is about. So we're going to start from let me enter the full screen. Okay. So what is data analysis? All right. So like I said, data analysis is a skill, right? And it's also a set of it's a process, all right? It's a process of transforming, cleaning, um, um, preprocessing data, raw data, all right, into useful insights, right, that can support business decision making process, right? So you collect data, right? You collect this data, you look at the data, you investigate the data, and then you try to see if there's a need for you to do cleaning and transform the data. All right. And then if there's any for you to also do data modeling, these are the things we're still going to be talking about. You can model the data as well. All right. All of this is basically to be able to generate useful insights, all right, that can help drive business decision making process. Okay. So what that means is that your analysis should be able to drive certain business decision. Do you understand? So if a business probably is not making profits or is not making sales, right, and then you are given a kind of a messy data to work with, and then they ask you, okay, how do we optimize revenue performance or sales performance in our business, right? And then you as a data analyst, your role is to look at the data, investigate the data, see if it is messy, see how you're going to transform it or clean it or model it, right, in order to gain useful or actionable insights, all right, from there and visualize it and tell a story, all right, that supports, you know, business decision making process. So what that means is that whatever out of that business decision making process, there is a recommendation that you are given to the stakeholders about the business that okay, from what you've generated, from what you've discovered, from the patterns and behavior you've discovered from the data, all right, this is what the business or the company should do. All right, maybe they should increase stock in of a particular product in social area and reduce the number of stock for a particular product in social area, something like that, right? Or they should pay attention to you know, or channel resources to So all these are actually recommendations that came from you analyzing a data. Do you understand? So that is what what we mean by saying you are actually performing data analysis. Do you understand? So do you get what my explanation so far?
Yes, I understand it.
All right.
I'm a bit. It's
Okay.
new to me, but I understand. I think I grasp the general process of it.
Okay. So we'll be taking it step by step. Now, there are different types of data analysis. All right. As a matter of fact, we have four major types of data analysis. So the first one, so sometimes you might need to take some notes while I'm talking. Of course, there is a note that I'm taking as well, so you get that as well. All right, just pay attention. And then if you have any question, you can always use the raise hand button or drop it in the comments in the chat. All right, so we have we have four major types of data analysis. Number one, we have what we call um descriptive analysis. All right. Number two, we have what we call prescriptive analysis. Number three, we have what we call predictive analysis. Number four, we have what we call diagnostic analysis. Okay. So let me say it again. We have descriptive, we have prescriptive, we have predictive, and then we have diagnostic. Did you get that?
Yes, I got it.
All right. Now, I'm just going to try to explain these different types as we go on. I'm going to give a better explanation to them. Now, when we say descriptive, so basically we are saying what happened. All right, what happened? What happened? What is the root cause? Do you understand? What happened? Do you understand? What is the root cause? What triggers it? What causes this business revenue to be declining? So what happened? So what that means is that you're going to be working with historical data. Or when we say historical data, it means that they are past data, right? So it can be a day old data, it can be 2 days old, 1 week, 1 month, 2 month old data, 5 years old data. All these are historical data. Okay. So you have historical data that you want to analyze to be able to discover trends and patterns within the data. Do you understand? So let's say, for example, you want to analyze monthly sales report to find which product lines generated the most revenue. Okay. So something like that is descriptive, and it's descriptive because you are going to be, using statistical methods or functions to be able to calculate, you know, to know which products, let's say, generate the most revenue. So let's say, for example, you have products um, data, right? And then you also have a sales data. Now, in this product data just contain, let's say, the product name, right? The product category, and then the ID of the product, right? Because for every product, they have their own unique ID. Okay, so there are things we're going to talk about foreign care and primary care later on. So they have their unique ID. Now you now have a sales data. Now this sales data probably contains sales ID, contains the order date or purchase date, contain let's say contain revenue, contain price, contain quantity, and stuff like that, right? And then you are interested in finding which product generated the most revenue, right? You want to know, based on your analysis, to know, okay, which product generated the most revenue, which product is declining, all right, in terms of revenue. So what that means is that you might need to perform a descriptive statistics, so which is basically saying that you might want to either do sum, or you might want to do average, you might want to do mean, which is something as average, all right, on a particular data. And that data is going to be your sales, all right, column. Because in a data set, right, we have what we call rows and column. Do you understand? Have you seen a spreadsheet before?
Yes, I have.
Yeah, so a spreadsheet contains rows and columns. So rows is horizontal, columns are vertical. All right. So let's say that spreadsheet is your data set, is your sales data, and then one of the columns there is sales. So what that means that you need to aggregate sales. So let's say you want to do total sales, right? So that total sales that you did there is actually a descriptive statistics, right? Because you are aggregating that particular column, and then you want to now see, compare it as against products. So you now know, okay, for each product, what is the total sales that was generated. So from there, you will now know, okay, which product is the least, all right, in terms of revenue performance, or which one is the most, all right, in terms of revenue performance. Can you see that? So you're comparing products to what? To sales, to total sales, right? So with that, you can say, okay, this product is one with the highest revenue. This one is one with the least revenue. Does that make sense?
Yes.
All right. So that kind of analysis is what we call descriptive analysis. All right. So with that, you can use that to investigate, all right, to understand trends and pattern within data, to know, okay, which one is declining, which one is doing well, or which one is, probably in between, right? So that's what we call descriptive analysis. Okay, descriptive analysis. And then the second one is what we call prescriptive analysis. All right. So prescriptive should give you an idea. I'm going to give you an idea, all right, of, let's say, maybe someone is feeling the symptoms of, he's feeling sick. Let me use that word. He's feeling sick, right? And then, you know, you were told to visit the hospital. You know, the first thing they will do is to run a test, right? So they will run a test on you to know, okay, what actually caused the sickness, right? Right. And then what can, after running it, and then they're able to discover, okay, this is what is causing it, which is, you know, um, this is what is called, this is the root cause of, this sickness. And then there is, they will not say, okay, go and see a doctor for prescription, right? So maybe you need to take certain medication. Okay. Now, that doctor that you are visiting is the one that is going to prescribe. Can you see the word prescribe? It's going to prescribe certain medicine and dosage that you need to use or take to be able to what, get better, to get well, right? So, when we are saying prescriptive, means that there is a recommendation that is coming after, analysis has been, you know run, right? So that that recommendation that will now spur, an actionable step, for them to achieve either a higher target or increase in revenue, optimize results, optimize performance, and stuff like that. So prescriptive is saying my goal is to make it happen, right? My goal is to make sure that, oh, business are optimized, revenue performance are optimized, profits are achieved, all of those things, right? That's prescriptive because recommendation is involved. As a matter of fact, for every analysis you are going to be doing, you are going to be having to have what we call recommendation. Are you with me?
Yes, I am.
Yes. So you have to do recommendation because that recommendation is what the stakeholders need to see. All right. And it's not a guesswork. It's not, I think. Do you understand? It's not, oh, I think that we should do this. No, it's not, I think. It is not a guesswork. As a data analyst, you don't guess. As a data analyst, you can't say, I think. You understand? You are deriving your fact, right, from the a fact in this sense means recommendation from the analysis you have done. Do you understand? So you are providing recommendation for them so that they can now take those recommendations as actionable steps that needs to be implemented. So that by the time they implement it, they should be able to see results. Do you understand? In whatever areas, whether it is revenue, whether it is growth, whether it's employee performance status, and stuff like that. Do you get it?
Yeah, so you're just basically using the data that has been given to you to recommend to the people or to the stakeholders
Mhm.
what next to do.
Exactly. After you've analyzed it, do you understand?
Okay. Yes,
Yeah.
please.
After you've discovered patterns within the data, right? So that is what we are saying by prescriptive analysis. Okay. So
Yeah.
that is how it is. That is how it works. So basically, recommendation is involved, right? Good. Now, the next one is what we call predictive. Predict. Predictive is from the word predict. It means that what will happen next, what will happen, right? Now, and this one involves statistical methods, right, or models. So what that means is that you'll be doing forecasting to determine future outcomes, right? And how do you do forecasting? You can only do forecasting or prediction based on historical data that you have, right? So you might likely want to, forecast or predict, the sales or the revenue that probably the company can make, in the next quarter. Do you understand? Based on the historical data that you have with you that you've analyzed. So you've seen, okay, based on this trend, I think we are going to make times two of the revenue that we made in the first quarter. Can you see? It's not a guess, like I said, it's not a guesswork. It's not I think. It is from the trend that you've been able to what discover within your data to be able to say, okay, I think we need to increase our stock, all right? Because from the previous analysis of the historical data that we have, we discovered that in certain seasons, right? Um, revenue increases based on purchases of particular products. Can you see that? Based on purchases, or if there's a need for them to, develop a promotion program, like say, okay, if we can probably give a 5% discount on social product, we might likely have times two of the previous revenue that we generated in the first quarter. Can you say that, something like that? So this is predictive. Predictive is more of you using statistical models and forecasting to determine the future outcome. Does that make sense?
Yes, it does.
Exactly. Exactly. Right. So with Power BI, we're going to be doing forecasting, right? Of course, there are advanced algorithm that could be used as well to predict, a future outcome. But that is not the focus. All right. So maybe in the future, when you start learning Python, you can now, begin to talk about how you can build a machine learning algorithm that can help you that can help you predict the next outcome based on previous or historical behavior. Do you understand, of your data? So that's what we call predictive analysis. All right, predictive analysis. All right. Do you have any question so far?
No, I understand so far.
Everything is good. All right.
Yes.
Very well. So let me ask you again, what are the types of data analysis that we've talked about so far?
Okay, so we've spoken about descriptive, prescriptive, predictive data
Okay.
analysis.
All right. That's good. So now let's go to the next one. Let's go to the next one. So the next one, is diagnostic analysis. I'm current. Okay, so yeah. So the next one is diagnostic analysis. Okay. Now, diagnostic means why did it happen, right? Why? What led to this outcome? Yes, it's different from what happened. I don't know if you get it. It's different from what happened. Now we're saying why did it happen, right? Why did it happen? Maybe maybe somebody has been eating too much um too much carbohydrate food, and that's why it's having kwashiorkor, right? So why? You understand? Or um there's a malaria symptoms in your blood, is why you have malaria. You understand? Why? You want to know why. Why did it happen? So diagnostic analysis is a type of analysis that helps to probe, all right, why an event or why an outcome keep happening. Do you understand? So so it's not just words. What is different from what? So why did it happen? All right. Um, please give me a second. I want to get my charger.
Okay.
Okay. All right. So I was saying, why did it happen? Right? Why did it happen? So that's basically what diagnostic analysis is saying. Like the example I gave, right, before. Why are we having a decline in sales? All right. Is it that the marketing pers- um, personnel are not doing their job, or we're not doing promotion, we're not doing promotion enough, or promotional offers enough, or our marketing strategy is it wrong. So this is what we call you trying to, find out why. Do you understand why this is happening? Do you get it now? And all this is also dependent on historical data. Do you understand? Why are our customer leaving us? All right, we're having a shun in customers, right? You want to know why they leaving? Is it that the app, the app, the user experience of the app is not good enough, or are they having checking out error, or transaction is not successful, or there's this delay in transaction. I mean, depending on the space or domain, because all these things that can be applied in so many domains. I hope you understand what I'm trying to say. So it can be applied in health, data analysis can be applied in finance, right? It can be applied in the aerospace. I mean, in different space, HR, um, limits, oil and gas, you know, different company, different domains. Do you understand? That's why when you see different data analysis role, you see pricing analyst, policy analyst, HR analyst. I don't know if you have seen something like that. Inventory analyst. So
Yes, I have.
those are specific to domains. Do you understand? You see research analyst, you see markets research analyst, you see, health analyst. I mean, different kind of analysis rules. All right. So it now depends on the domain of your own choice. Let's say, for example, maybe you're into mass, like you said, mass communication, right? Media and mass communication. We have what we call brand analyst, right? We have what we call communication analyst. Do you understand? So,
Yes.
so
Yes.
yeah, so you can apply data analysis there. As far as there is data, as a matter of fact, there is data everywhere. There is data everywhere, which is the next thing we're going to be talking about, right? Because you need to understand what data means, all right? The sources of data and stuff like that. So there is data everywhere. Everywhere we generate data every day, every day, every day. So whatever domain it is, there is data, enough data that has been generated. It's just for you, somebody to say, oh, where are these historical data? Can we pick it up? Can we analyze it? Right? And let's see if there are patterns, trends that we need to discover or uncover within this data, and which we can use them to, you know, and generate actionable, insights and recommendations that can help the company to move from point A to point B. Do you understand? Something like that. So yeah, so there is data everywhere, right? So it is not left for you to say, okay, I want to apply this my knowledge of data analysis in so roles, So it depends, right? And let me tell you something, data analysis is the same thing everywhere, right? But in terms of application is where you now need to say, okay, I've learned about data analysis. I've taken a skill or a course on it, right? So how do I apply this in, let's say, in the business world, in the business domain? Maybe you want to function as a business intelligence analyst. What does that mean? All right, meaning that you need to be able to understand business outcomes, right? And whatever business outcomes has happened in the past, we want to be able to gather them together, see, analyze, those metrics or KPIs around those business outcomes, and then, see the kind of insights you are able to generate, and then the recommendation that can come from there, and then you can present that to your stakeholder and say, okay, this business outcome in the past has led to so loss in profit, in this, in that. I think from your analysis, I feel that we should go in this direction, because from this visualization, you can see that, we went through this route, and then our KPI, let's say our profit KPI reduced by so percent. So and I was able to discover that we shouldn't go this route, we should have gone this route, something like that, right? That can say, oh,
Yes.
I mean, they are seeing they are not, you are telling them a story, they are seeing the visual, right? Because we're going to be doing data storytelling as we move on. All right. So they are seeing the visual, you are telling them the story, you are able to take them take them through a journey, and then they're able to say, oh, I think we took the wrong decision. All right. And the reason why we took the wrong decision is because there was no data analyst to be able to analyze our historical data and give us the direction to go. Because as a data analyst, you are meant to give clarity, you're meant to give direction to every organization or businesses. Do you understand?
Yes.
All right.
So yes, yes, I understand.
Okay.
So you remember when you mentioned I'm trying to delve into
Okay.
brand analysis as well as communications analysis. So just
Okay.
a side note.
Yeah, yeah, it's good. It's good. It's good. So what that means is that, these are the things that you need to learn. You need to learn this. Like I said, all these Excel, whatever, they are just tools, right? You need to understand what data analysis is all about first. All right.
Yes.
uh so when you understand it, you can now begin to use those to, to so maybe we can probably get data. I can tailor our kind of data based on your domain. All right. Maybe you are looking towards mass communication. So we can generate data from there. Now with AI, now you can generate synthetic data, and then you can also use that to, analyze and
Yes.
stuff. So these are things we're going to be doing, and I'm going to be showing you how it is done. So it's not like, oh, I will just, generate it and then just send it to you. We're going to do it all together. So you see the secret of how this is done. All right. So that when you walk into a company, a mass communication company or something like that, and then they say, okay, we have this data. All right. And then these are the metrics. All right. And these are the categorical data and stuff like that. Okay. How can you help us analyze this data that can help our brand, to improve our brand awareness and stuff like that, improve our brand awareness, improve our strategy and stuff like that. So you'll be able to pick that kind of a data, and then you're able to what? Analyze it, right? If it is messy, you clean it, you transform it, all right? You set up your KPIs, you're able to analyze and visualize it, and then you're able to, from the analysis and visualization, you are able to derive recommendations, right? And then from those recommendations, you can now develop what we call an executive summary note that you can present or send to stakeholders, right? So that with that, they see the summary note, they see the recommendation, and then they know the next line of action to take, all right, going forward. Do you understand?
Yes, I do.
All right. Yeah, so the other types of analysis, right? So the other types, we have what we call exploratory data analysis. Okay. So exploratory data analysis basically saying that what does the data show? What does the data show? As a matter of fact, exploratory data analysis is what we call EDA, right? Exploratory data analysis. It is called EDA. E for exploratory, D for data, all right, A for analysis. So we call it exploratory data analysis. It's actually a statistical techniques, all right? It's a statistical techniques for um it's a statistical techniques for analyzing and visualizing data to discover trends, patterns, variations, seasonality, within data, right? Within data, um, so that kind of insight can help improve business decision making processes. Do you understand? So it's actually a technique. So that technique is what we're going to be employing, all right, as we look at Excel and Power BI as we move on. All right. Now, there are three types of EDA. Okay, there are three types of EDA. Number one, we have what we call univariate analysis. Univariate analysis. Okay, univariate analysis. Number two, we have what we call bivariate analysis. Bivariate analysis. And then number three, we have what we call multivariate analysis. Right? Multivariate analysis. So univariate means one. When you say uni means one. So it means that you are picking one variable or one column of your data set, right? And then you are trying to understand the distribution of that particular data, all right, to know the trends, to know if it is skewed, if it is spreading, towards the right direction or towards the left direction. All right. You want to know the frequency of each data point within that particular column. Okay. So it is basically you analyzing a single column of a data set. All right, to understand distributions, patterns, and all that within that particular data. Right. So that's what we call univariate. Now, bivariate means two. What bi means two? Bi means you are comparing two um, data. Now, like I said, we're going to be talking about data next, right? So you're comparing two columns. So columns could be numerical, it could be categorical, all right? It could be numerical versus numerical. So basically, you're just trying to make a comparison between two columns, and so that with that you can understand the distribution, the underlying distributions, within that data, the trends, the patterns, within that data, all right, whether there is a relationship between them, and then what kind of relationship exists. Is it negative, is it positive, or neutral? And what is the depth of this relationship? All right, that is what we mean by bivariate analysis, which is what we usually do most of the time. Most of the time, we perform more of bivariate analysis, all right, most of the time, because we try to compare, all right. We want to compare this against this. We want to compare products against revenue. We want to compare category against profits. You compare most of the time. So we can do two comparisons, all right, comparing two columns together. And then multivariate means you are doing more than two columns. All right. So you are looking at gender as against revenue and as against maybe payment methods that they use in performing transactions. All right, that is multivariate because now you are involving three columns, right? More than two. Okay, so that is what called by multivariate analysis. All right, so we're going to be looking at EDA as we move on, in much detail. Like I said, this is just introduction. All right, so that's basically what EDA is all about. All right, and then when you are doing EDA, it is also important that you plot or you visualize, your analysis. All right, so that's that. And then the last one here is what called sentiment analysis. Okay, sentiment analysis. When we say sentiment analysis, we want to know the tone, we want to know the emotion, all right, emotional tone of your customers. Do you understand? How are customers perceiving your brand or your product? All right, do they have a positive perception of a product? Do they have a negative perception of a product? Do they have maybe some people are just they are not sure. So with those ones that are not sure, we call them neutral, right? So sentiment analysis basically is you analyzing data to understand the emotion, all right, emotional tone or perspective, all right, of your business or product. Do you understand? Whether it is positive, whether it is negative, or it's just neutral. You understand? So, for example, people use social media platforms to gain perception of their products. So, what are people saying about our products? All right? Do you get? So they do that. So they pick up they do a marketing campaign, for example. So they run a marketing campaign, and then when they run those marketing campaign, people begin to say, oh, this product is good, oh, I've used this product, oh, it's very nice, oh, so all those things are coming from reviews, right? um
Yeah.
so this product is very nice. Some will say, oh, it's not that good, but it's not bad. So those ones is neutral. Some say, oh, this product is worse, This is the worst product I've used in my life. That is negative, right? So with that, you now begin to say, okay, what is the rate of the positive, and what is the rate of the negative, and what is the rate of the neutral? So probably by the time you analyze that, you know, okay, you discover that 78% of the people said positive things or gave positive reviews of the product, while 22 let's say 20%, gave negative, review, and then maybe 2% said they are not sure. So with that, you know that, okay, how do we now improve the positive? Because we have to be on the positive track. All right. So what that means is that we want to reduce the false negative and then improve the true positives, right? So how do we ensure that, okay, people keep buying our products? What are the factors that is leading to these negative reviews? Because from there you will also see part of the review. They will tell you, "Oh, the charger of this phone is not strong, and this one is not this." If you are the types that is probably into accessories, oh, I bought a charger and then I bought a fan, or the battery is not good. So you know what you need to optimize. You understand? So that kind of analysis is what we call sentiment analysis. Does that make sense?
Yes. I have a question.
All
So
right, go
you
ahead.
know that you mentioned marketing campaigns in
Mhm,
sentiment analysis. What
mhm.
tools do people use to be able to get the data? Like, are they just sitting down and manually going through comments concerning a product? Because I feel like if you do that, you're prone to missing things. So
Very.
what tools?
So this is a good question. Actually, sentiment analysis is done using tools like Python. All right. So basically, what that means is that, let's say you do a marketing campaign now, right? And then people are interacting with your with your ads advertisement, right? And then they are giving comments and reviews and stuff like that. So you can scrape. So there's something called scraping. There's something called web scraping. Okay. So you can scrape, not web scraping, sorry, web crawling, but they are two different things. So there's web scraping and there's web crawling. Now I'll tell you the difference between the two. So web scraping basically means you are extracting the content on a particular website, all right, and then storing them in a file format, maybe PDF, Excel, CSV, and stuff like that. Okay. But web crawling basically means you are extracting data, all right. You are extracting data um from a website, right? You are extracting the data from a website. So you are not completely scraping everything. And you see, on that website, well, web scraping is about scraping all the information, all the content there, but scrolling in, saying that, okay, for this particular part of the web, right? So let's say you are using X or Facebook, for example, and then you went to your ad, and then there are comment there. See, you are not scraping all the content on Facebook. You are basically crawling the parts, right, that you need. Can you see, from Facebook, which is probably your comments, right? So let's say from your ads, you have like 1,000 comments, right? So you're crawling, extracting data from that part. That's what we call web crawling, all right? So when you extract that kind of context, right, you can now store them in a CSV or Excel file, right? And then after that, you now need to do sentiment analysis. Now, the sentiment analysis can happen using Python, all right, because Python is a tool, it's a programming language um that can do so many things, all right. So you can write a script, or you can write a Python script that helps you to detect the different tones within that particular crowd data that you've stored in a CSV file, right? So that you now know, okay, which one is positive, you put them in positive, which is negative, you put them in negative. So it will run through the whole data, and then structure it for you and say, okay, this is positive, this is negative, this is neutral. So because you can't be manually have to do that on that particular web page, right, or marketing campaign. No, that will take a longer time, and then it's not just going to take a longer time. You're going to miss out on certain important reviews or comments, right? So is why we put sentiment analysis as an advanced data analytics. Can you see? So it's not beginners. All right, it is advanced. So what that means is that if you want to know how to do web crawling, right, how to do sentiment analysis, you now need to learn what we call Python, all right, programming language. So it's a programming language, all right. But if you don't want to do programming language, and then probably you want to be able to extract comments from the marketing campaign ads you've done, now we now have what we call AI, right? So you can feed the URL to an AI assistant that can help you, because we call it an agentic web crawler. So you can help you crawl every comment or reviews from your products, from your ads, right? And then you tell it to also structure it in a way that you want to see, the sentiment types, right, for each of the reviews or comments. So whether it is positive, whether it is negative. Positive means yes, negative means no. All right, neutral is neutral. Do you understand? So you can do that. You can use an AI assistant to do that. So if you don't want to, board yourself with having to learn Python, but the limitation with using AI is that if the data is now very large, when I say large, meaning that let's say the numbers of rules or records that you have is up to 1 million records. So it's gonna consume time, all right? And then there will likely be a bit of hallucination from the AI. You understand? So that's the limitation. So the best thing is to go the deterministic way, which is having to write a script, all right, that runs through each of the rules, all right, categorize the text into different sentiment types, all right, and then with that, you structure it as a structured data that you can now probably visualize. So you can say, okay, for this review, this is the sentiment. All right, for this review, this is the sentiment. All right, and then you can also even do further SQL analysis on it. So, okay, how many times did people say poor, bad in our, and then which product exactly? So because you can also compare it as against products as well. So these are things that you can do, but this is advanced data analysis. So it is not something you will need to know now, right? So you need to understand the basics first to probably an intermediate level where you can say, okay, I think I've known this one, then I can now go into the advanced data analysis. Do you understand?
Yes, I do.
All right. So any question on sentiment analysis, is it clear to you?
Yes, it is. It's clear to me now.
All right. Okay. So I think that's that on data analysis. And the next thing I want to talk about now is data. Data is like the fuel, the oil. And some people call it the new oil. All right. Data is the new oil. Actually, is actually data is the success behind everything, AI right now. So data is like is very important in whatever thing you want to do as a data analyst, as a data scientist, as a data engineer. Data is is the driver. All right. So and this data comes in different formats. So we're going to talk about it. But first, what is data? All right. What is data? What do you think data is?
Information.
All right. Information. So data is raw information. Okay, raw information. Data is raw information. Data is unprocessed information. Um, yeah, unprocessed information, right? That needs to be processed, that needs to be collected, that needs to be processed, that needs to be analyzed to solve business problems, right? So that's what data is. Now we have types of data, okay? But we have types of data, so we need to take note of all these parts because this is, like I said, it's foundational, but it's very, very important to your journey as a data analyst, your learning journey as data analyst. All right, as data analyst is very, very important. So we have types of data. We have what called qualitative data or categorical data, and then we have what called quantitative data or numerical data. Do you get that?
Yes.
Okay. So qualitative or categorical data, and then we have quantitative or numerical data. Okay. So now, what is qualitative or categorical data? So qualitative data is basically a type of data that are usually in text format. All right, in text format. So what that means is that when we say in text format, it means that it can be collected through interviews, through surveys, live presentation, questionnaires, right? I mean, you are into max communication and brand marketing. Let's say, for example, you want to interview somebody, right? Now, the interview you are doing before the age of audio devices, probably you might want to transcribe, like writing what the person is saying, and you have to write very fast. I mean,
Yes.
yes. So those are actually text, right? They are in text format. Those words are in text formats, right? So um, they are, like I said, they are usually in text format. So qualitative, categorical data are usually in text format, right? So and they are gotten from interviews, surveys, live presentation, questionnaires, and stuff like that. And then the number two is what we call quantitative or numerical data. Now this is type of data that are in numerical format, right? They are usually in whole numbers, integers, or decimals, right? Whole numbers, integers, or decimals. For example, price of an item, right? Price, sales or revenue, profit, right? These are numbers, right? So basically, what you call KPIs, key performance indicator, they are usually numbers, right? Numbers, okay? Numbers. Do you
Yes.
get that?
Yes, please. I got that.
All right. So now let's not go further. So we want to go deeper into the different types of these data types that we've talked about. So for example, under categorical data, we now divide categorical data into two. So we have what we call nominal data and then we have what we call ordinal data. So please take note. So for categorical data, so we have what we call nominal data or ordinal data. So what is a nominal data? A nominal data is a kind of data that you can, that you can not put into rank, right? You can't put them into rank. You can't put them into order. It's like you can't order it, right? They don't belong to any hierarchy. Does that make sense?
Yes.
So for example, race, race, right? Race of people, whether you are Hispanic, whether you are American, whether you are African, whether you are Indian, Asian. Do you understand?
Yeah.
You can't put this race into any category, right? Race is race. You understand? The same thing with color. Color is color. You can't say that your color yellow is more is is better than color blue. You understand? I mean, you can't rank them. You can't say color yellow is one. Color yellow, color blue is two. You can't rank them. Color is color. You understand? So the
Yeah.
same thing with location. All right, location, address, all right, phone brand, gender. You can't rank gender. You can't say male is better than male is number one, female is number two. You understand? I mean,
Mm-hmm.
you guys preach gender equality, right? We want to be equal with men. All right. I mean, that is actually the truth because God didn't create God didn't create man to be better than the women.
Yes.
Do you understand? No, it didn't. It just their respective roles that are different. You know, so man roles is different from the women's role, right? So there is nothing like, oh, it is only the female that only men that can do this kind of a job. What happened to the women? How can they do the job? Right?
Mm-hmm.
So like they say, what man can do, the woman should be able to even do better. Right? Yeah. So you can't put them into hierarchy. So this kind of data is what we call nominal data. Okay, nominal data because you can't rank them. You can't put them into order. All right. You can't put them into order. You can't rank it. Okay. Then the number two is what we call ordinal data. Now, these are the ordinal data, basically, you know, types of data you can put into pecking orders, right? You can put them into hierarchy, all right? You can put them into rank. Do you understand? For
Yeah.
example, for example, job positions. I mean, you will have seen different job positions out there. They'll tell you we are hiring for a senior role. Some will say mid-level role. Some will say entry-level role, right? Some even
Yeah.
say executive. Okay, so that is hierarchy. So within an organization, all right, there is what hierarchy. So you have the the chairman, the executive director, like that, right? You know, going down to supervisor and then the employees, right? And then amidst the employees, you cannot begin to have senior, mid-level, entry. So these are kind of data that you can put into rank. Okay, the same thing with customer rating. All right, customer rating. You can put customer rating into numbers. All right, so five probably excellent, four very good, maybe three good, two poor, one very poor, that kind of stuff, right? It's basically rating, right? So, I mean, customers can rate your product, can rate your services, they can give you 2 star, 3 stars, and stuff like that, on my LinkedIn page, I have services parts, right, on my LinkedIn page, and then some of my students, gave ratings of my service, right, towards them when they came for training. Some of them gave me 4 star, some 5 star, all right, some 3 star, all right. So, and then they're able to also comment based on those stars, all right. So that shows you that that kind of data, right, is that there's a rank, right? So you can rank those that give you 5 stars, those that give you 2 stars, 3 stars, like that, all right. And there's the same thing with grades in school, right? We have pass, we have fail, we have excellent, stuff like that. And then grade A plus, grade B, grade C, So all these kind of data are types of data that you can put into pecking order. So we call them ordinal data. Do you understand?
Yes, I understand.
All right. Any question?
No, I understand so far.
Okay. All right. Um, that's good. So so let's go to numerical data. Numerical data. So numerical data has two types. So we have what we call discrete data, and then we have what we call continuous data. So discrete data, continuous data. All right, discrete data and continuous data. So when we say discrete data, they are actually countable data. All right, they are countable data, they are finite data. They take on a specific value. All right, they only take a specific value. For example, let's say you are in a house, right? I don't know how many people live in your house, like in your
Two.
house, two. So So you have two people living in your house, two people. You cannot, you cannot, you, okay, let me say, I wanted to say, you dare not say you have 2.5 people in your house.
Yeah.
You dare not say that because, I mean, who is the half person?
Yeah.
So whether you have one, whether you have two, whether you have three, they are countable. That's what we call it, countable data, right? So you can count it, all right? The same thing with cars. You cannot say I have 10 and they have cars. I have 10 cars, I have 20 cars, I have two cars, three cars. You cannot say you have two and they have cars. So that's why we say it is discrete. It takes on a specific value, all right? It takes on a specific value.
Yep.
They are countable, they are finite. You understand? You can't go into the supermarket and say, okay, I want to buy 10, 10, 10, and they have, tin of milk. It's not possible. Do you want them to cut the tin into two parts? It doesn't make any
Mm-hmm.
sense. So the same thing with sachets. Oh, I need 12 sachets. I need 10 sachets of milk. You cannot say you need 10 and they have sachet of milk. It doesn't make any sense. All right. So these are examples of discrete data. Discrete data. All right. Discrete data. Then number two is what we call continuous data. Continuous data. Continuous data. Now, this continuous data, all right, they are data that can take any value within a given range. And they can also exist as a fraction or decimal, right? They exist as a fraction. They can be measured as a fraction or decimal values. So for example, your height, your weight, right? Your height, your temperature, right? Your height, your weight. Your height when you were 5 years old is probably not different from when you were, 10 years old, right? The same thing with your temperature. Your temperature in the morning will probably be different from the temperature you have in the afternoon. You understand? So
Yes.
now the continuous data changes with time as well. It changes with time intervals, right? The humidity in the morning, right? The humidity in the morning, right, will probably be different from the humidity you have in the evening time. All right. So maybe it is much cooler in the evening time compared to in the morning time. Right. So this is continuous data. The same thing with price of an item or price of product. You can see now that the price of products varies. All right. You can even get to different location and they will tell you that, oh, the price of bottled water in this place is 3,000 naira, whereas in another place it's just 300 naira. All right. So it changes.
Yeah.
You understand? So that kind of data is all called continuous data. So example, price, weights, age, weight, profits, right? All these are continuous data, right? So most of the time, when you are dealing with finances, right, or financial data, most of the time you are dealing with continuous data because your finances, um, your finances changes, right, almost every time. You understand? Changes almost every time,
Mm-hmm.
right? Yeah, because the money you will spend this month probably will be different from the amount you're going to spend next month, and stuff like that. So how much you are recharging today, but probably be different from how much you're going to recharge in the next 30 minutes, right? So it is continuous, right? It's continuous. So um, there are places where we use this continuous data, especially when you are dealing with predictive analysis or forecasting. We use continuous data. You understand? So we use for continuous data because we want to discover the trends and pattern within that data and then predict the next outcome. All right. So what's going to be the price of Bitcoin in the next 24 hours? Bitcoin has a price right now, right? And then can you predict in the next 24 hours what will be the price of Bitcoin? What does that mean? It means that you have to gather all the historical data around Bitcoin, all right, let's say the last 10 years, and then analyze it and then develop a model that helps you to predict the next Bitcoin price in the next 24 hours. Does that make sense?
Yes, it does.
Yeah, so that is continuous data because it changes with time. It changes with time. So there are other types of numerical data like ratio. Ratio basically means you are comparing, right? So you're comparing magnitudes. So you have um eh, let's say you have like a fraction, right? So let's say you have 2/3. 2/3 is even saying 2 ratio 3, right? Or you're comparing years. Let's say I'm comparing my age with your age now. That is ratio, right? I'm 36, probably you're 26, right? I'm comparing my age with your age. Okay, I'm comparing my shoe size with your shoe size. That kind of comparison is also continuous because I mean age value changes, inches of stuff changes, right? Um, Something like that, right? The same thing with intervals as well. So all these are other examples of numerical data. Okay. Any
Yes.
question so far?
None so far.
All right. All right. Okay. So we are gradually getting there. So there are different roles. Like I said, there are different roles in data. There are different roles in data. So data analyst is just one role in data. We have other roles like data engineering, data scientists, machine learning, um, database administrator, um, artificial intelligence engineer. All these are different kind of roles. Business intelligence analysts, right? I mean, cloud infrastructure analysts, cybersecurity analysts. I mean, these are different roles in data. Okay. So, but our goal here is basically to focus on data analysis, right? With respect to a domain. So you need to understand those rules and what they do. All right. So my first assignment for you, so maybe you need to write it down, is that write write out 10 rules in data, all right, and what their function is. That's the first assignment. So write out. So I'll drop it in the chat. All right. Number one, write out. So you can just do research. Write out 10 rules in data and their function. You get that? Do you understand?
Yes, I got that. Yes,
Okay.
10 rows in data and their functions.
All right, good. So do do something around that. Okay. So we are starting with Excel. Now, for us to start with Excel, so we need to look at what is Excel, and then what are the things that you have within Excel. All right, and so probably in the next class, we'll have to be doing some hands-on practical stuff. So I'm going to share some data with you that we're going to start with. All right, and then as we move on, we'll now probably generate the synthetic data and stuff like that. So so I think I've talked around data analysis so far. I've talked about different types of data analysis. I've talked about data, types of data. So there's one thing I also need to talk about, which is not on these slides. So probably I might need to share my my whiteboard. So I want to share my whiteboard. So we have what called data. So we have what we call. Can you see my screen?
Yes, I can.
Yeah. So we have what we call data types. So let's start with formats first and types. Can you see what I'm typing?
Yes, I can.
So yeah, data format and types. So so like I said, data is everywhere. As a matter of fact, based on research, um, the kind of data that we have are mostly generated by voice or audio, images, charts. I mean, the kind of data that we have out there are mostly generated by interactions, via charts, audio, images, videos, and stuff like that. So data formats. So we have three types of data format. Three types of data formats. So number one, we have what we call unstructured data. Unstructured data. The data can be in unstructured form. Number two, we have what we call semi-structured. And then we have what we call structured data. You get that?
Yes.
So I said we have unstructured, right? We have
Mm-hmm.
semi-structured and structured data. Okay, so I'm going to define these three, all right, one after the other with the examples. Okay. So what are unstructured data? Unstructured data are types of data that are usually in texts, audio, videos, images, all right? And they cannot be put into a tabular format. Do you get that?
Yes.
Yeah, so there are types of data that are usually generated through videos, images, audios, texts, and they cannot be put into a tabular format or table. So that's what we call unstructured data. So when I ask you what are examples of unstructured data, what are you gonna
I
say?
was going to ask you just now, like, okay, so examples, do you mean like, say, I run a campaign and the metrics, I take screenshots of them and then I share the screenshots. Is that a sort of unstructured data?
Very good, very good. Clap for yourself. That's a very good one. So that screenshot is actually an image, right? So that is an unstructured data.
Yes.
Yes, that is an unstructured data. So you screenshots, um, all right, and then that screenshot is saved as an image, all right. So that is an unstructured data, all right. Or you copy a text from a conversation that you have with someone. That also is what an unstructured data. So when
Unstructured
I ask,
data.
yes, when they ask you what are the examples of unstructured data, so you can say texts, videos, images, audios. These are examples of unstructured data. And as a matter of fact, 80% of the data that we have in this world are unstructured data. 80% from research. All right. They are what? Unstructured data.
Unstructured.
Yeah, unstructured data. Okay, so that is clear. So what we use to develop what we call AI today are actually unstructured data. Most of the work we use to develop AI models are actually unstructured data. Images, text, and all that are unstructured data. It is the reason why you can upload an image to maybe ChatGPT, for example, and then it's going to analyze the image and give you and tell you what the image is about, and tell you, and extract the text within the image, and I mean give you the analysis of the image. Do you understand? So why? Because
Yeah.
that that model has been trained with unstructured data, with images, with texts, with audio, with videos as well. All right. Of course, their sizes are different because for videos they are more heavier than audio. Text is more is I mean, text is like the least. I mean, maybe it's in kilobytes, but most of the time, anything audio, images, videos, their size is usually higher. So now let's come to semi-structured data. So what are semi-structured data? Now, semi-structured data are data that are not in tabular form, and they are not unstructured. All right, they cannot be put into a tabular format, and but they are not also unstructured. So they stay in between. You understand? They stay in,
Yes,
and I will give you an example. So example is what we call HTML. Have you heard about the word HTML before?
I have. I'm
HTML.
trying to figure out where I've seen that. Um,
HTML.
I
So
have. I've heard of it.
okay, they have what we call JSON.
Okay, I haven't heard of that one.
JSON. Okay, we have XLM. So we have JSON, we have HTML, we have SLM. I think these are the known ones, and then we have some. We have dictionary. So we have dictionary. I'll try to show you example, no worries.
Okay.
Visual, basically. So dictionary. Dictionary. Okay, so what is HTML? HTML basically is hypertext markup language. All right. And then this one is Excel language markdown. All right, XLM. And then this one is JavaScript notation. All right, JavaScript notation. So JSON. And then this one is a data structure dictionary. Now, HTML is basically what we use to write to develop our website. If you remember, what you call your website is actually is a combination of HTML and you know some other programming language. So we started building with HTML. Okay, we started building with HTML. So let me
Yes.
show you an example of what I'm saying by HTML. So I'm going to go to which one can I go to now? Okay, let me go to this platform. So it's what HTML is about. So HTML has a head, it has a body, and it has an end. So I'm going to inspect this guy, this web page. And I'm going to go to sources. Okay, this is elements. Now, if you look up here, I don't know if you can see. Let me increase it a bit. Okay. So if you look up here, you can see doc type HTML. So this
Yes,
now,
I can see.
yes, this now, it has a that's a beginning. So you start with HTML. You can see less than HTML, language, English, and then you have different words within that. And then that's a body. All right. So this is basically the head. That's a body, right? And then it has an end, right? So this now is semi-structured. So it is not, you can't put it into a tabular format, and it is not unstructured. So that's why we say it is semi-structured. All right. So this is HTML. For this page, part of the page, this is written in HTML with some other frameworks, right, within these scripts. Okay, so this is what we call HTML. So HTML start with less than HTML and then ends with greater than HTML greater than, right? So this is it here. So this is the end. This guy here is
Yeah.
the end. But this is the beginning. Okay, so this is semi-structure. Now JSON, an example of JSON, an example of JSON. So I'm just going to write. So you see example of JSON format. Good. So there's an image here. So I'm going to click on it. All right. So there's an image here. So I'm clicking on the image. So you can see how JSON looks like. See if I can expand it. Yeah. So can you see my screen?
Yes, I can see your screen.
So this is JSON. All right. This is JSON. This is sample JSON. So we have a curly bracket. You can see start with a curly bracket and then it ends with a closed curly bracket. So there's an open curly bracket. There's a closed curly bracket. Now this is data. Okay. It's also data, but this is semi-structured data. You understand? So you start
Yeah.
with an open curly bracket, it ends with a closed curly bracket. And then within these curly brackets, we now have what we call strings, because I'm going to talk about data types very soon. So now we call strings, all right? We have number, all right? So basically, this part here is what we call dictionary. From here, this part I highlight from this type to this 33.9. This is what we call
Mm-hmm.
dictionary. Yeah, so a dictionary is actually a data structure that has both that are key value pair. We call them key value pair. So the key there is the type, the value there is the basket. The key here is the beans, the value here is 47. The key here is apples, the value here is 7. So it has a key value pair. So just like the way you have a data set that has columns and values within each column. So that column name is the key. And then the values within each column is what we call values. Do you understand? Do you get that?
Yes,
Yeah, I can show
I
you.
understand.
Okay, I'm coming. Let me show you something. Good. Now, can you see my screen, please?
Yes, I can see your screen.
Good. Now, this is a spreadsheet. Now, this spreadsheet contains month, face, tax ID, blah, blah, blah. Now, let me pick face. This face here is the key. It's actually a column name, but it's a key in a dictionary. Right? Now, each of these rows or cell within each column, within this column called face, is a value. Does that make sense?
No, I don't understand.
Okay. So this face is the key for a dictionary. I want to use a spreadsheet so that you get it very well. So this, when you have a spreadsheet that has columns and rows, right? I'm saying that
Mm-hmm.
your column name, this is your column name or column label, right? Is
Yeah.
actually a key in a dictionary. Why
Okay.
the cell here is your value. Do you understand?
Okay.
The
I
cell is
understand.
your value. But this spreadsheet that has many values, so it's a list of values. But in what I showed you now, in this place, it just has one value, which is basket for this key called type. Does that make sense?
Mm-hmm. Yes, it does.
So what I'm saying is that this part here is actually a dictionary. So a dictionary can actually be converted into what you call a table or a spreadsheet or a data set. Does that make sense?
Yes.
Yes, but that one it is an advanced analytics. That's why you now need to learn Python. So As when we are doing Python, I can show you how you can convert a dictionary to a table. All right. So,
Mm-hmm.
so this is an example of a dictionary. So a dictionary, a JSON is, I mean, there are all examples of semi-structured data. Do you understand?
Yeah.
Right. XLM, XLM is also similar to HTML, all right? But this one basically is they use it in graphics, graph visualization. Let me just use that word. Or maybe you want to, you want to um so there are certain language that you write that can help you visualize a particular text, right? So, I mean, it's more like before you will have what we call Python and stuff like that. Within Excel, there is also a language inside it that you can use to convert, something like a text. It's not text, but it looks like HTML. But by the time you run it, it's going to return an image for you. Do you understand? An image. So that is how XLM looks like. So all these are example, all these are example of
Semi-structured data.
semi-structured data. So now let's now go to structured data. So structured data are data that is in tabular form. Tabular what form? Like the example I gave to you in this spreadsheet now. All right, this spreadsheet, this guy is a structured data. This guy is a structured data. All right, this is structured data.
Okay.
Yes, this is structured data. Anything table, structured data. Anywhere is a table, structured data. SQL database, structured data. All right. Tables, structured data. Structured data. SQL database, structured data. You understand? So a database is also
Yes.
structured data. All right. So a database. So when you say a database, it's actually structured data. So anything table is structured data. So it means that you can put them into tabular form. All right. Any question?
No, I understand so far.
All right.
The
Okay.
XLM, HTML, JSON, and dictionary.
Mhm.
I need time to digest them,
Yeah, yeah,
but
yeah. I mean,
I understand.
it's not something that you'll be dealing with as a data analyst, but I just need to let
Okay.
you know. All right, because most of the
Yeah.
time as a data analyst, what you'll be working with is structured data. Most of the time, like 99% of the time, you're going to be working with a structured data. So you're going to work
Okay.
with the spreadsheets, with a CSV file, with a PDF that has tables, with a database. Do you understand? These are the things that you're going to work
Yes.
with. All right. You will not work. I mean, programmers are the ones that work with this one. You know, programmers, HTML, JSON, programmers are the ones that work with this. Software programmers. We work with these guys. You understand? But you is structured data. So don't
Okay.
be too bothered, all right, about semi-structured and unstructured data.
Okay.
All right. So now let's now go to what we call data types. Data types. Very, very important. Data types. So data types are, excuse me. So data types. Sorry to write data types. So they are the they are the they are the let me use the word they are the form or um I'm trying to see the best word I can use. So I don't want to say format, right? They are okay. So data types basically is a form in which your data, right, um possess. So let's say, for example, now, I've talked about categorical data, I've talked about numerical data. right? Now,
Yeah.
for numerical data, we have what we call whole number, all right? We have what we call decimal. Can you see? So decimal
Yes.
is the form of a particular data. So if I say 11 points, if I write 11 points, let's say I write 11.2. Now, this 11.2 is actually a number, isn't it? But what type of data is it? Is where we now say, oh, this guy, oh, it's decimal. It's decimal. Some people call it decimal or float. Decimal or float. So this is the form in which this data, because this 11.2 is a data. This is a form of this data called 11.2. So it's a decimal, a float. If I write 20, 20,
Yeah.
20, this 20, right? The form is actually what? Whole number, because a whole number or integer. Whole number or what? Integer.
Integer.
Yeah. Whole number. So you need to understand this thing. Or integer. All right. So when we say whole number, they are numbers that they don't have decimal point. All right. But decimal numbers or float numbers are numbers that has a floating point or decimal point. You understand? So
Yeah.
give me another examples of whole number.
30.
Very good. All right. So you can name it. They are uncountable. All right. So this is integer. And then we have another one. So if I write dummy dummy sorry dummy is home already. Now this statement, dummy is home already. What kind of data type is it?
I want to say it is integer, but I think it's an integer because
Mm,
it is asserting
mm. What did I say integer is?
a whole number.
So can
Something that
this dummy is home
no,
already? Is it a whole number? Is it a
no,
number?
it is no, it is that was my confusion.
Okay, good. So this is actually, we call it text. So text is actually data type. So text.
Okay. Text
So
is a data type.
yes, please.
Yes.
Text. So I'm writing it. Some people also call it string.
Mhm.
So text or string. So that's what I need to explain these things. So dummy is home already. It's a text or string. So basically your statement is a
Okay.
text or string. Your statement is a text or string. But most of the time, when you see them in either in Excel, especially when you are, so sometimes you will see them in quotation, in either single quotation or double quotation. When I say quotation, something like this, quotation like this. They have a quotation here, like a quote. So they are within a quote. That's what I mean by quotation. All right. So it can either be a single quote or double quote. Do you understand?
Yes.
So this is text or string. So text or string is also a data type. Okay. Now let me write this. When I write 2026 dash 0 dash 05, this, what data type is this?
Um I think that that is a text, but it's date.
All right.
Sorry,
It is date
I'm not sure.
actually. It is date.
It's date, but okay, okay,
So,
okay,
so we have what we call date. So date is a data type. All right.
okay.
Date, yes, your date is not just a text, it is date. All right. Date is
Yeah.
a data type. Date is a data type. This is date. And date has different formats. So some starts with year, followed by a month,
Mm-hmm.
followed by day. Some is month, year, right? Day. Some is
Mm-hmm.
day, right? Month, year. Do you understand? So these are the different
Yeah.
formats of dates. All right. Now, I want to write another thing.
Mm.
So if I write something like this, let's say I write, let me use another color. All right, 2026 dash 07 dash 21 dash 11 column 20 column 45. Let me zoom it a bit. Now, what is this? What data type is it?
Date and time.
Very good. Date and time, but we call it date time. So we call it date time. So you are trying. Hold on. So this is called date time.
Okay.
So this is called date time. Date time. Okay, date time. So this is called date time. Okay. We've mentioned 1, 2, 3, 4, 5. Good. So these are the core data types that you need to know. So we have text or string, integer or whole number, date time, and then we have decimal or float. These are the core ones. Now the other ones, all right, that we mentioned. Now those ones, so when you are learning, maybe in the future when you are learning SQL, they're going to teach you that. So we have what we call char, we have what we call voucher. Money is also data type. Money or currency. Money or currency. Let me just put them together. All right.
Yeah.
Then we have small ints. They are still under integer. All right, small ints. Um, we have which one again? So all these ones are under, you might probably be seeing them under SQL. So char basically means fixed character length. Voucher means varying character length. You understand? The money
Yes.
see is also data type. So you can have dollar, you can have pounds, euros. So the most more int is actually a smaller size of integer, like a byte size of integer. All right. So we have
Okay.
integer 64, we have integer 32. All right. So these are just a byte of integer. All right. So all these are the other examples of data type, but the core ones are the ones I've just shown you: text, string, whole number, integer, um, dates, date time. There are some other ones I'm still going to talk about, and maybe we'll get the Power BI or maybe in Excel. We have binary as well. We have binary. The binary is we have Boolean. So let me just write it. So we have binary, we have Boolean. Boolean is true or false. All right, which is true or false. Then binary is also a data type, but it is used for storing tables. For storing tables. So it's for storing or hiding tables. So Boolean, and so these are just other examples of data types. Any question?
None so far.
All right. So I think this is where I'm going to stop tonight. So today now we've talked about data analysis, right? Talking about what data analysis is. It's a process of transforming, cleaning, modeling, analyzing and visualizing data in order to get actionable insight that can help improve business decision making processes. And then we also talk about types of data analysis. We talk about prescriptive, descriptive, predictive, diagnostic, right? And then we also mention other types of data analysis, right? Exploratory data analysis, sentiment, and other ones like that. And then we'll talk about data, what data is, types of data, and then we're also able to look at um, the data formats and data types. Okay, so in the next session, we're going to be going into Excel fully. All right, so we're going to Excel fully. We'll just teach you some basic things around Excel, and then we're going to Power Query. All right, Power Query in Excel, and all those things. We're going to be looking at those things. So it's going to be on some practical stuff in the next session. All right. Do you have any question for me?
No, I don't.
All right. I hope you enjoyed this session.
I did. Thank you.
All right. So let's catch up again on
Thursday.
Thursday. Yeah, same time, 6 p.m.
All right.
So
Okay.
I'm going to
Thank
send
you.
you the recorded session. And then the
Okay.
assignment I gave to you, if you can do it and send it to my DM, that'll be fine.
Okay.
Before that.
Okay. No problem. Thank you.
All right. Enjoy the rest of your day.
Okay. Bye.
Yeah, bye.